Lesson 5.9, Wright Polynomial Functions and Models. You've probably been asking, when will I ever use this? Today we're going to model a few situations with polynomial functions. If you have the x-intercepts in one point, we could write the function as factors with an a in the front, such as this, where p and q are the x-intercepts. And of course, if there's more x-intercepts, you just continue putting more factors. Use your other point, you plug it in for x and y, and you can solve for a. So let's write a polynomial function with x-intercepts -2, 1, and 3, and passes through the point 0, 2, which incidentally is the y-intercept. So the first thing we need to do is write it in factored form with an a. So it'll be y equals a, x minus a minus 2, or x plus 2, x minus 1, x minus 3. So it's x minus each of the x-intercepts. Next, plug in your point, the 0, 2, for x and y. The x is 0, the y is 2. So I fill in 2 for the y, 0 for the x's. Simplify. 2 times -1 times -3 makes 6. So 2 equals 6 times a. Divide by 6, and a is 1/3. So now that we know a, we can write our function. Just take what we had before, here, this one, and replace the a with the 1/3. Otherwise, it gets more complicated. And to build up for that, we need to show that nth order differences for the given function of degree m are non-zero and constant. So we need to find values of the function for equally spaced intervals, and then find the differences of the y values. And then you find the differences of those differences. And then you find the differences of those differences, and you repeat until they're all the same value. For example, show that the third order differences are constant of, and notice it says x cubed. The order of difference is the same as the degree. So we need to make a table. So I pick some x values, plug them in, and find the y values. So if you plug in the 0, you get a 1. Plug in the 1, you get a 6. And then we're going to subtract the y values. So 6 minus 1 is 5. 25 minus 6 is 19. 70 minus 25 is 45. 153 minus 70 is 83. 286 minus 153 is 133. So that's our first order. Now those are different, so let's do the second order. So subtract those. 19 minus 5 is 14. 45 minus 19 is 26. 83 minus 45 is 38. 133 minus 83 is 50. And then, since they're different, repeat. Subtract those. 26 minus 14 is 12. 38 minus 26 is 12. 50 minus 38 is 12. Notice we did 3 levels of subtractions to get them to be all the same. So the third order differences are all the same. They're all 12 in this case. Since the third order differences are the same, we know the degree is 3. So again, because the third order differences are the same, the degree is 3. So if we're given several points, we need to find the degree of the function by finding the finite differences, where the degree is the order of the constant non-zero finite differences. Then we write our function in basic standard form, such as this for cubed, or if it was to the fourth, you'd have f of x as ax to the fourth plus bx cubed plus cx squared plus dx plus e, and so on. We'd fill in x and y, or f of x, with points. and use some method to find a, b, c, and d, such as Cramer's rule, or a graphing calculator using matrices, or a computer program, or substitution or elimination. So let's find a polynomial function to fit these values. Notice they're written as f of x equals a number. So the number in the parentheses is x, and what it equals is the y. So we're going to use the nth order differences to find our degree. So we list the x's, which are the numbers in the parentheses, because it's f of x, and then the y's that go along with them. We need to subtract the y values. So 2 minus negative 2 is 4. 12 minus 2 is 10. 28 minus 12 is 16. 50 minus 28 is 22. And so on. Those are different, so let's subtract again. So now we have 10 minus 4 is 6. 16 minus 10 is 6. 22 minus 16 is 6. 28 minus 22 is 6. Notice they're all the same. Since the second order differences are constant, the function is degree 2. Since it's degree 2, we could write it in standard form of y equals ax squared plus bx plus c, where the degree is 2. So to continue, there's our list of values. We decided it was quadratic. So we're going to plug in 3 points because there are 3 letters other than the x and the y. The x and the y are required for a function. The a, b, and c, however, should be numbers. So I take the first point where x is 1 and y is negative 2. The next point where x is 2 and y is 2. And then the third point where x is 3 and y is 12. Those came from right up here. 1, negative 2, 2, 2, and 3, 12. You can simplify those to get these 3 equations. Now we're going to solve those like we did back in chapter 3. You could use substitution or elimination or Cramer's rule or an inverse matrix. I'm going to use my calculator and an inverse matrix. So I hit matrix, edit, matrix A, which is the 3 by 3. This will be the coefficients. The 1a, 1b, 1c, 4a, 2b, 1c, and 9a, 3b, and 1c. Then we need a new matrix, so hit second matrix, and you want to edit matrix B, which is our constants. So it'll be 3 by 1, and put in our constants, negative 2, 2, and 12. Now to solve this, remember, is the inverse matrix times the constant. So we hit matrix, pick matrix A, raise it to the negative 1, times matrix B, enter, and there you go. As you can see there, the first number was 3, the second number was negative 5, and the third number was 0. So A is 3, B is negative 5, C is 0. So our function is that after we have filled in A, B, and C from that quadratic equation. Your calculator can also do regressions. You can push stat and then go down to edit. You enter x's in the first column and the y's in the second column. Then push stat again, go over to Calc so we can calculate our regression, and we choose it. For our last problem, it was quadratic, so we chose quadratic. Push enter. We get a new window here, so I make sure that X was list 1, the Y was list 2, and pressed calculate. And it gives us the A, B, and C. So we have our equation. If you did not get a new window, just push enter again, and it should give you the equation. So you just have to read your answer. You can do the same thing with Microsoft Excel. Enter your X's and Y's into 2 columns. Insert an XY scatter chart. In the chart tools, go to the layout, pick trend line, and then more trend line options. And pick the polynomial trend line and enter the degree of your function. And make sure you pick display equation on chart. Click done, and your answer is on the chart. That's it for this one. Have a good day.